Hello everyone, today I'm going to be following up on a video I posted yesterday where I discussed some things that may go wrong when animating meshes along a spline. These problems are not unique to the tool I'll be referring to throughout the video, and in most cases are fixed with an option in the engine itself. This spline mesh blueprint I made is free to download from this link on Fab, or if you could pay a small amount to help continue the support of these updates and our Discord support server, it would be greatly appreciated. In return, you'll also get the demo level we reference in our videos, which has meshes, blueprints, and information that you could refer to at any time. Some of the issues I'm going to cover in this video are blurry meshes when animating, uneven spacing along a spline, teleporting with meshes, and camera jitter from being pushed by animated meshes. Let's start with blurry meshes, which I feel like I'll hear about quite often. You get this type of blurring if you have a similar scene using deformable meshes or instance periodic meshes that are being animated at very high speeds. The thing mostly responsible is your anti-aliasing method. By default, UE5 uses TSR, which seems to be the culprit. Even though you may have a high-resolution monitor, it's fairly obvious when an edge has a weird step effect due to pixel approximations. The purpose of anti-aliasing is to blur your image to make those sharp edges seem more natural. Each anti-aliasing method just specifies how much your image is blurring and where. The specific problem with TSR is that it depends on something called motion vectors, which you may be able to guess is not supported by deformable or instanced meshes by default. There are a few ways you can solve this though. An easy solution is to just not use TSR. As far as I know, it's the only anti-aliasing to do this type of blurring. Personally, I think TSR is a good blend of performance and quality, so another solution is to adjust some of TSR's settings from the command line. The command r.tsr.shadingrejection.flickering is set to 1 by default, meaning it's on, but if we set it off using 0, we can see the blur is no longer there. Another option is to set the flickering period to 0. I believe that does pretty much the same thing though. You may be able to get away with just setting it to 1 or some other low number instead of the default of 3, if your material, geometry, and movement is less sharp. Lower periods equate to less ghosting but more flickering. The example you see now on screen is part of UE5's documentation on it. Weirdly enough, you can also keep using TSR with no settings change if you use NVIDIA's DLSS plugin. As many of you probably know, DLSS is kind of a way to fake performance by generating interpolated frames. There are a lot of opinions about it, but my opinion is that it doesn't hurt to add it to your project as an option, so that your users or players can decide for themselves if they want to use it. But interestingly enough, DLSS overwrites TSR's need for motion vectors by just interpolating between real frames, so with no motion vector issues, the blurring is fixed. The next issue you may run into is uneven timings of the animation. If you look closely at the cubes I'm standing on, they sometimes get closer or further away from its neighboring cube. This is because splines are approximations, they're not actually smooth curves. Unreal Engine stores a list of locations along the spline between each segment. If it ever goes from overestimated to underestimated, it will look like the meshes are shifting. The only solution I know for this is to increase the quality of the approximations. The variable responsible for this is reparam steps per segment. More steps will lead to better approximations, but it will also lead to shaking in smaller distances, slightly increased CPU usage, and slightly more memory usage to store these recorded values. Let's look at a side-by-side comparison of the steps per segment at 4 steps, 25 steps, 50 steps, and 100 steps per segment. At 4 steps, which is the lowest this variable is allowed to be, we can see it has wide areas of clumped meshes and extreme gaps. It's really bad. And then at 25 steps, we can see more of that fast shaking between cubes. And then at 50 steps, it looks pretty good. And then finally at 100 steps, which is the highest amount of steps blueprinting allows for, it has no shaking and is hardly different from 50 steps. If your meshes are still shaking at 50 or 100 steps, you should consider adding more spline points along your path, since it will increase the number of segments. By default, UE5 uses 10 steps per segment, which you now know how to override if you ever have issues. I actually noticed this issue when I opened the game Satisfactory for the first time, because the menu screen has the items shifting as they travel along their conveyor belt splines. You can see it if you look closely, but given the amount of conveyor belts in the game, I think it's reasonable that they set the reparam steps per segment variable to be a lower number. Another issue you may run into is teleportation. The player can be teleported with the mesh as it loops back to the other end of the spline. It's actually a bit difficult to recreate the situation where this happens by accident. We need a mesh that repeats at the start of the spline, right after the end in a fraction of a second. We can do that by making the animation speed really high or having a really low placement distance, meaning the distance between meshes is really small. Some people may see this teleportation as a positive, but I recommend finding another mechanic to handle teleporting because it may not always reliably teleport your player. The way this teleporting works is that the character maintains its position and rotation relative to the mesh, and when the mesh reaches the end of the spline, it gets reused and is placed back at the start after a small delay. If the delay lasts longer than a few frames, the player gets unassigned from the platform, and the platform continues without the player, and no teleportation occurs. The trick is having the platform reappear quickly enough on the other side so that the player is still considered on the platform, and teleports with it. You may notice on this other spline that there is a mesh at the very start of the spline and a red version at the very end. They are all evenly spaced out, but when this starts animating, the mesh at the end has to wait for enough space before being allowed to be animated on the spline again. It waits in this limbo state, and a larger gap between meshes means more time in limbo. This longer time in limbo gives more time for Unreal to realize the player's not standing on the platform anymore. So now the question is, how do we disable this teleporting for this conveyor belt example? Let me preface this by saying there are multiple different solutions, but I think I found one that is ingeniously performant. Some would say lazy, but oh well. We can just add a plane at the end of our conveyor belt and size it to the dimensions of it. We don't have to really concern ourselves with the look of it because we can set it to be hidden during the game with this setting. Now, all other meshes will most likely be able to skip right over this invisible plane due to momentum, so they will act relatively normal. The player will most likely be stopped because he's not purely a physics asset, and he'll have this platform he can step on that will prevent him from being teleported. If you need the player to fly off the end of the conveyor belt, I recommend a trigger box and add an impulse node to the player character. The last issue I'm going to talk about is using animated meshes to push players. The problem that we are experiencing is not because of the camera or the wall, but actually gravity and the character's movement component. The friction of pushing the player while gravity is exerting a downward force is causing this jitter effect. The movement component when active will actually make the pushing smooth, but in blueprints there's no way that I know of to make it continuously on. Maybe I'm missing something with wake all rigid bodies or using CCD, which is continuous collision detection, but once again I found another ingenious solution for our problem. It's another plane. This time it serves as a ramp at the bottom of our mesh to act as a temporary floor, so we are picked up by the ramp and then pushed smoothly. There's no need for extra code or other systems that would slow down performance. I'm just using a blueprint that has a cube wall and a plane ramp, and having the natural physics system do all the work. I also found this issue repeated in the Talos Principle 2 DLC with these walls of animated meshes. In this instance, there's no reason to approach the wall and it's not meant to be a mechanic, but if you are going to add it as a mechanic to your game, I recommend solving the issue so your players don't get a headache from the jittery camera. Those are all the issues that I found in this update that might occur in your scenes from animation, but if you run into anything else, let me know on the Discord server, which there will be a link for down below. A lot of the fixes that were introduced in this update were brought up by you guys in the Discord. Thank you for helping make this a better tool. That's all for this video. Until next time.